Join me as we turn a pile of scrap into a welded together pile of scrap. No, that's not right. A brush sander. Yeah, it's a brush sander. Right, this is the general arrangement of how I'm going to make this brush sander. There's the main tube that all the pieces are going to be bolted to. At this end there's a 500 watt motor with a plate salvaged that fits it, salvaged from another an old project that I no longer need. And this is my test embryo brush. Doesn't have any brushes on it, but this is just a test piece. Works brilliantly. So that's going to fit that side. Oops, apologies for that. I've got this old washing machine drum pulley as an example, and we're going to have it's going to be smaller and that sort of thing. And I need, got a couple of salvaged bearings, and the first thing is to turn this into a cartridge with two bearings in it. So I need to lop this off at the right length. Done myself a little sketch. By gum, that's light. Done myself a little sketch so I know what I'm doing. So I just need to slice a chunk of that off. Here I am checking the undercut is deep enough so the flange will sit flush. Once the part has been flipped over, I've dialed it in to make it run concentric so that the bearings will be concentric in the top and bottom half of this cartridge. This is a simple way to index the spindle. to mark off the hole positions in the flange. It's a clinometer that's yeah, a cheap DRO type bit of kit. They're only a few quid on eBay. If you set the jaw to be horizontal and mark your first line, then you can spin the chuck round until you hit 30 degrees, 60 degrees, 120, etc. And just keep marking off the positions. Really easy. This plate will eventually be the circular drive platter. Just checking this boss is long enough because I'm going to heat shrink fit this part into the drive platter. A couple of hours in the freezer should make it nice and small. So here we go with Terry the torch, and once we've got this platter up to temperature, we just pop in the drive shaft and away you go. Here we go.
What fits?
I've found parallels and engineer squares are the easiest way to mark off these quite awkwardly shaped parts. Lovely. This crappy mill enclosure I built has got a window at the one end that you can pop out, which is very useful if you've got a long bit of work. Right, this is where I've got to with my flat sander or stroke brush sander. Here's my my test brush that I made. I've used this for a few weeks now and it's absolutely brilliant. However, I've been using it in a drill press. That's not really very good. So this is my where I've got to with making a dedicated machine. So this is will be the main frame. You saw me machine up a cartridge, fits in there, there we go. This is going to be the drive shaft and platter, so that fits in a treat. So that's how far I've got with that for the moment, so let's put that to one side. Ideally these things need to be run with variable speed so that you can control how much material they rip off. It's very gentle, this one anyway, but this is, I think this is 220 grit, and it hasn't lasted particularly well. So I've actually got some coarser paper down in the factory that I will I'm going to make another 2 or 3 of these because to start with I need a hex hole in the middle. And this was just a test piece. So I've turned my attention to drive system, and this is the motor out of a scrap washing machine, and here's a variac to drive it. So it's, there you go. With a variac we've got variable speed. This is 450 watts, and I've tested its no load maximum speed at 22,000 RPM, which is shifting. Under load it won't be anywhere near that, and I need to limit it anyway. These things, I'm told, need to run at no more than about 700 RPM, so I need a big reduction ratio. The drive pinion on there fits one of these multi-tooth belts, and that's 15mm in diameter, and this is the normal pulley you get on the back of a washing machine. This is too big for this application, because if I show you, look, it's just too close to the outside diameter. You'll be constantly banging your work into the edge of this, even though it's going to be, you know, that sort of distance away. It's still too close for a long piece of work. You will long piece of wood you're denibbing, it will you'll still catch that. So that's too big. So that's out of the way. So I think this is 150mm or 6 inches in inferior in diameter. So with 150mm down to 15mm, there's a 10:1 reduction ratio. If I make a hub, a drive pulley the same diameter of this, and I do happen to have I've got a bar of steel, a long piece of this, which is just shy of 150mm. So I'd get 145mm out of that, if not a bit bigger, which would be ideal. So that's my next task. tapping this hole proved to be a bit of a pain. This is the only way I could think of doing it. Here we go with a quick test just to make sure it's all going to work. Just working out exactly where to mount the motor so that the drive belt doesn't fall off. This may look like I'm playing, but actually I'm really seeing if the drive belt is going to fall off. In other words, did I get the motor in the right place? Up next are a few safety guards. This guard came out okay. I'd go as far as to say it's even semi-professional. Right, here we go. Finished as far as I can go. I'm still waiting for an electronic speed controller to turn up, but I'll give her a quick clean up with the wire brush and then paint it. Right then, these are all the parts for my brush sander. So they've been sprayed, as you can see. So let's put them together. I've had a week or so here to for the paint to harden. So it should be relatively easy to put together. Let's start with the spindle. I think. Right. Get that out of the way. We'll put the safety guards on. There we go. I'll tell you what, I'll do that off camera. Right, let's see. We're in business. Right. I'm going to have to run this with this variac for the time being because, like I said, I'm waiting for this circuit board to turn up. Right, there's a brush. There'll be a link up in the where is that? A link up here somewhere, I think, probably for how to make these. But this is designed to be quite quick in changing them. So there we go. That bolts on like that. A little cover, which I think I might chemically black. I'm not sure yet. But anyway, there we go. There we have one brush sander. Now, what's the point in buying a brand new microphone if you don't switch the bloody thing on? So the bit that's missing from here is me waffling on about how I'm going to make a little wooden dust collection cover that sort of goes round half of the disc of the sanding pack. And yeah, I waffle on for a while. You'll see further on down the video. Anyway. So we're looking at some weird 41mm. That's really odd. Is that some kind of imperial unit? What is that? So what do we have here then? We have 90. Right, there we go. In order to prevent shorts from the back of the board, what we're going to do is put some tape. There we go. Now when we fit the circuit board, it's going to be a lot less likely to short on the case. So I just deburr those and we're away. I've marked out the position of the main switch. I'm going to go in there, and right there is where the pot will come through for the control knob. I haven't got a control knob yet, but I've got a 3D printer on the way, so I think I might make a fancy one. Anyway, okay, I've put the holes in for the pot and the main switch. I've also added another hole in the back there for the incoming cable gland. So let me get this. I'll get it wired up off camera, and then we can have a little look and see what I did. Then you can criticise me for bad practice. Fully wired up, so the circuit board is mounted in the back. There's the power cord coming in. Yet to put a knob on it, and on-off switch. Now, so starting here at the jolly old UK plug, 3 amp fuse. The power consumption of this is 500 watts. 1 amp fuse wouldn't be enough, so a 3 amp fuse is the next one up. That's the way to start. Okay, so the power comes in, goes up to the main switch. Not very easy to see. Goes up to the main switch, and out of the main switch into the circuit board, and then from the circuit board off to the plug for the motor. In the interest of safety, because this is metal, it's a metal cabinet or a metal machine if you like, the incoming earth from the incoming main supply is taken off to a spade connector which fits on the earth lug on the motor, and just let's take that off for a second. That earths the motor but may not necessarily earth the case. So the case, I've taken another spade connector off the other side and connected directly, that round so you can see it, directly into the main plate here. Scraped it clean, put the connector, screwed the connector in with an M4 screw. So this is, these two, the motor and the case, are bonded together, and that should solve our earthing issues. So all that remains, oh, the other thing is, just to point out again, underneath the circuit board is some red, in this case it's gaffer tape. I would prefer to use something a little more sturdy, but I don't have any insulator in stock that's suitable. A bit of printed circuit board would be ideal, that sort of thing, but this should be okay. So all that remains is for me to put it all together and put the dust extractor on, and then we'll switch her on and give her a go. So let me just screw it all together. Right then, let's give it a go. Turn it on. There we go. Rotating. Fair bit of torque. And variable speed. Right, let's just put one of my sanding brushes on. Give it a go. There we go. My word, it takes the dirt off your fingers a treat. Right, this is the last bit to add. Put this dust extraction hood on, and I need to find a knob for it, or I'll make one, I'm not sure yet. Right, here we go. Hey, find some of the sand, some wood. There you go, you can see it just rounds things off and takes denibs, if you're gentle with it, really well. I'll show you this working in the factory, and so you can see whether or not it's something you want to have a go at yourself. Also, I think I'll make another video on how to make these brushes. This is just an experiment, this one here. It's made of paper-backed emery paper, and the pieces keep falling off. Stay tuned, thanks for watching, hit the subscribe button and the notification bell, and we'll see you on the next one. Hopefully we'll make this. Cheers!